with us this evening. Melissa Bravo is our most recent addition to our cooperative extension group here in New Jersey. She comes back to us with a very nice background. She got her bachelor's degree from Delaware Valley College and her master's degree from Penn State University. She has experience in working in a variety of different venues of agriculture. She has a lot of experience with crops and agronomy, but she has experience with animals as well. We are certainly glad to have her with us this evening and look forward to her talk. Hopefully, as time goes on and she gets more entrenched in our system, you'll have other opportunities to interact with Melissa, and I'm sure she is. For those who are, I failed to mention her, she's in Salem County. And for those of you who are in the southern part of the state, especially Salem County, please, if you have a resource there in the county that you can go to when you have needs. With that, I'll turn it over to Melissa as our first presenter.
All right. Good evening, everyone. So tonight's presentation I'm giving you is on the current hay market situation with a focus on quantity and quality. And my name is Melissa Bravo, and I'm the Salem County Ag Agent. And I've put my contact information on the screen. You can reach me at melissa.bravo@njaes.rutgers.edu. You're welcome to reach me by cell phone. And if you reach out and contact me by email, I can send you a link to my grower survey as I get to know the producers in Salem County. So today's presentation, I'm going to take a look back at the mid-Atlantic hay season, the hay species and crop progression in 2020, and then look at what our current dry hay composition, quantity, and quality might be, with focus on weeds, pests, and pathogens that may occur in droughty times. So on the slide here, I'm focusing on the mid-Atlantic hay acreage in Pennsylvania, New York, Ohio, West Virginia, and New Jersey. And I'm looking at the non-alfalfa acreage in 2019 compared to the alfalfa acreage in 2019. And you can clearly see that there's a tremendous amount of hay acreage in Pennsylvania, New York, Ohio, and West Virginia, ranging from 920,000 acres in Pennsylvania to 500,000 in West Virginia, and then New Jersey with 80,000 acres. And that's data that's reported to the National Agricultural Statistical Service. You can look that information up in their Quick Stats program. And the yields on non-alfalfa acreage, which would be your grass and your mixed grasses, range from 1.7 ton in West Virginia to 2.3 ton in PA. And the prices in 2019 ranged from 110 to 179 a ton. When we look at the alfalfa acreage reported in 2019, a lot of our alfalfa is coming from Ohio with 330,000 acres, 290,000 acres in New York and PA, and quite a bit less in West Virginia and New Jersey with 15,000 and 11,000 acres. But the yields are quite higher. These were fairly decent yields for 2019, ranging from 2.2 tons in New York to 3.2 in Jersey. And the prices reflect that. We've got price ranges from 196 to 224 and up to 226 in PA. So for those of you who calculate your hay needs based on the units that you purchase, I went ahead and put together a slide to represent what those tons mean in bales. We have the range of 1.7 tons to the acre to 3.2 tons. That equates to being baled as small squares, 50 pounds, medium-sized round bales at 450 pounds, 750-pound bales, your larger round bales, and then your big squares that are on average around 900 pounds. And if you look at that, for 1.7 ton to the acre, we're getting about 68 small squares. And then on the higher end, on the alfalfa, we're getting around one square wagon load of around 128 bales. and upwards of 3 big bales for the lower end of the yield and up to 7 bales an acre on the higher end of the yield for alfalfa. And that's the hay that came into the market at the beginning of the year in April. What I have on this slide is a comparison of the Lancaster area hay market and the Leola, PA hay market for the week of April 18th through the 25th. And this is data taken from agmarketnews.com and their weekly Pennsylvania hay market reports. And what you can see here is there was a decent amount of hay coming into the market in April still for the 2019 crop season. Alfalfa had 12 loads, mixed hay was at 58, Timothy was at 9 loads, and grass hay was at 34. And the average price on those loads was $263 a ton for alfalfa, $281 for mixed grass, $192 for Timothy. My slides, so I can't see my screen on the end there, but up in the 200s for grass. But the range there for each of those is something to look at compared to what we're seeing in October of 2020. And the range on alfalfa in the spring was 172 to 305 a ton. Now, we can't tell quality on the low end of that unless you were there to see the loads, but we do know that on the high end, the 305 for alfalfa, the 402 for Timothy, the 237 for, or sorry, the 402 for mixed grass and the 237 for Timothy, those were your prime graded hays at the auction. Your alfalfa was in the premium range, early bud, and your mixed grass and Timothy were in the early boot. And the same was the scenario in Leola. But corresponding to just about the same time that that 2019 hay was going through the market, we had a significant cold snap hit the Northeast. And the slide here is information from the Pennsylvania Philadelphia Inquirer, looking at the National Weather Service data for the week of April 15th to May 14th. And that 30 days constituted the coldest such period in 54 years. And in fact, throughout the Northeast region and those hay areas that I mentioned earlier, we had 4 mornings of frost or freeze advisories. And not only did that impact our fruit production in the area because it knocked the buds off the early fruiting trees, it had a significant impact on our cool season grasses. So let's look at the impact on Timothy. Timothy's a perennial, and it's most productive at that first cut under cool temperatures. So we need that moisture in the spring and the early summer to produce that tall biomass to make those bales. The root system's very fibrous, but it's also very shallow. So if there's a shortage of soil moisture in the top several inches of soil, we see an impact in Timothy. And the new shoots develop from the nodes, and those nodes were impacted by that cold snap. Timothy is also what we call an obligatory long day flowering plant. So as we think about the long days of summer and the longer nights, it has a pretty set pattern as to when it's going to flower. But under drought conditions, the growth is very slow. So we know that Timothy is going to flower and stop growing at when it reaches that maturity stage at around 400 to 450 growing degree days, which is characterized here as GDD. And growing degree days are just how we try to track when a particular crop will mature so we can plan our harvest season and our inputs. And there's different base growing degree days for cool season crops and warm season crops. Timothy and some of your other grasses are done on a base 40. Alfalfa is around 45, corn is at 50, and so forth, up into your warm season grasses. And that's just looking at this graph, which I'll go into more detail. But as the season progresses, if there's temperatures above 40 degrees, the grass will start growing. And we look at how much growth can occur on any given day. So let's look at what happened to Timothy in 2020 because of that cold snap. So this graph is from the climate farm database that Cornell has. And I set it to a growing degree day of base 40 for northern Pennsylvania and Ithaca. And the graph shows you a green line, which is the season to date for Timothy growing beginning in January. The 15-year average is blue, and then there's a 30-year normal. And you'll see some blue vertical lines, and that's the average frost and freeze dates over the same period of time, calculated here for 15 years. And I drew in the 400 growing degree day mark, which happened to be May 23rd this year. And what you can see is we had that cold snap coincide with terminal end of that 400 growing degree days for Timothy. So the Timothy pretty much stopped growing, and it has had a significant impact on the amount of biomass of Timothy that you're going to see available this year. And to put that in retrospect to alfalfa, the the triangle there that's in red marks around the 680 growing degree day marker, June 1st, for when alfalfa reaches the optimum NDF value. So alfalfa had more time to recover after that cold snap. And this is what happened for those of you who are noticing the hay shortage and wondering where your specific species are. We had some growth from May 4th, but then nothing happened after May 14th. But in the northern tier counties of Pennsylvania and New York, that's when we're making first cutting hay. And we started to have some recovery, but then it went back to zero. And that up and down temperature didn't help at all to produce any biomass. And this is going to be seen across all the cool season grasses to varying degrees. Orchard grass was impacted less than Timothy, and that's because it's a perennial bunch grass. It doesn't have rhizomes or stolons, and it has a more extensive root system than Timothy. Most productive at that first cut under cool temperatures, but it is able to regrow and has pretty good tillering even after taking a hit like that in the cooler temperatures. And it's slightly more heat and drought tolerant than Timothy, which was a blessing this year. The next one that was the least impacted was brome grass. Brome's a perennial sod-forming grass with a very extensive root system, so it's able to acquire moisture down in crevices and in pockets where some of those other grasses don't go. And it's got really good winter hardiness. It has excellent drought resistance, and if you think of the type of soils that we have in those hay-growing regions, it grows really well on silt and clay loams. And then we have our fescues. Now our fescues are tall fescue and meadow fescue. There's improved varieties, but there's also a lot of background native species. And they're your perennial rooted tuft bunch type grasses. They have very short rhizomes, but they're very long lived. So they always remain in a field long after improved Timothy and orchard grass die out. And they do really well on acidic soils. And we have a lot of acidic soils in those hay-making regions because of the previous years of extensive rainfall. A lot of producers were not able to get lime on, and then with the economics of 2020, we're not seeing that lime application again. With the fescues, we do see 50% of that growth early in the spring, but it's got excellent drought tolerance. One of the downsides of that in hay is that it survives drought periods in a dormant state, so it's really not doing anything, and nutritional value shows in the hay samples. And the last one I want to touch on is Reed's canary grass. While it has its detriments and it's considered an invasive in certain areas, it is a sod-forming wetland grass because of its dense mat of rhizomes. And this is the first one to sprout in the spring, so it's a good early foraging species if you have wet areas that are dry. And it's also long-lived, so it's always coming back in as those introduced stands peter out. And in a year like this with drought, this is a go-to species. So you're going to see a lot of Reed's canary grass that may not have been baled in previous years that got baled this year. The offside of Reed's canary grass is that it's a pretty nice looking bale of hay. It's very light, fluffy hay, but it doesn't hold on to the nutrient density as some of our other introduced species. So we took that hit from the cold, and then we took the entire season long hit of it didn't rain. So what I have on the slide here is the precipitation ranks from June through August for the United States as just a snapshot of where we were at this summer. And this is from the National Oceanic Atmospheric website. And the colors across the United States are showing record driest counties out in New Mexico and Arizona and Utah, all the way across through New England in much below average, with just some pockets of record wettest up around the Finger Lakes and down in North Carolina. And right smack in the middle of Pennsylvania is much below average. And if you looked at that during the hay season, it actually fell into the recorded driest area. And that deficit of moisture carries into the acreage in Ohio and New York. So what I did here to show you how that accumulated over the course of the season and why it's impacted quantity is when we talk about those yields per acre, that's just not one cutting. That's one cutting, two cuttings, three, perhaps even 5 cuttings down in the southeast corner of the hay acreage. So here I have a drought monitor map and a series of them I'll show you that are created by the University of Louisiana called the Drought Monitor. And it's showing you the comparison of May 26th to April 28th. So we had that cold snap in April, and we're starting to see pockets of drought up in the Finger Lakes where we would see some of our alfalfa production. By June, when we would be hitting the second cutting mark, we're seeing some significant soil moisture, surface moisture deficits throughout upstate New York and all out through New England, in a couple areas in southeastern Pennsylvania. And then when we could have recovered, even though we generally July and through 28th back through June would be when we would start picking up our heat units of summer, you're seeing that drought deficit carrying all the way down through Pennsylvania and down into West Virginia. And on the other side, up in the New England states, you're seeing no change. So the drought's not changing, but they're not getting any increase in moisture to push that third and fourth cutting. And again, that carried into August and all the way through into September. We started seeing rain, and now we're getting a lot of moisture, but it's a little too late for the northern areas where we're making hay to make dry hay. So I want to show you what that looks like as a visualization. We won't know until the end of the year what the yield reduction was, but from the monitoring that I've been doing and looking at what's available on the market, I think we're going to see a 50% reduction in yields across the Mid-Atlantic hay region. And that's quite shocking for those of us who are purchasing our hay by the unit, because now there's only 34 square bales available per acre on the small squares for the lower tonnage. And for the good hay, for the alfalfa hay, we're looking at only 64 small squares. And you can see that lack of availability and the reduction in yield and what's coming into the markets now. There's not a lot of hay movement through the markets. This is October 25th through 28th. And again, I'm looking at the New Holland hay market in Pennsylvania, Leola and New Holland. And there's two things that stand out. There's very few loads. There was only 1 load of Timothy for the whole week, 3 loads of alfalfa in New Holland and just 2 loads in Leola, and the prices are quite high. The average price on alfalfa was $303, and the range was $280 to $340. Now we can't know, because we weren't there, if the lower end of that range was based on quality. I do know the higher end was premium hay, but that reflects into the mixed grass hay where the range was 180 up to 400 a ton. And you can see the same occurred at Leola. So just to recap that, if you've been wondering what's going on with the hay, there's also there's a hoarding situation. People are holding onto their hay because they're not sure they're going to have enough till spring. We still have some corn silage coming off, and then we're moving into our corn grain production. There is a fair amount of baleage out there, but that doesn't really move in the marketplace. The next part of the presentation, I just want to focus on, you're going to see some poor quality hay moving in the market, and you may have to buy it. It depends on your hay situation and what you're going to need to get you through till spring. So I want to focus on what to look for in those bales that you aren't used to seeing. So we can pull apart a bale and identify the grasses, and I've got 2 slides here showing you the different types of seed heads that you'd look for. Roughstalk bluegrass, tall fescue, orchard grass, cereal rye, annual ryegrass, and you may see some cereal grains from the cover crops that were planted in those previous row crop fields that were made into emergency hay because there was enough biomass there to bale. And then you have your branching panicle types of brome, the tufts of orchard grass and Reed's Canary, and then the spikelet of Timothy. So those are our desirable forage grasses. But we also have some, what we would consider less desirable grasses. They still have a nutritional value, but they have some issues. Those cuttings in May and early June are probably going to have mature foxtail in them. And the foxtails have a mastication issue. They're very prickery to be in the mouth of animals. And our fine grasses are red tops, and they're not so much a feed issue in the mouth, but they're so fine that they don't provide the cud chewing and the teeth grinding that a lot of animals need. And they make for a very soft bale and a small bale. And as I mentioned earlier, a lot of farms are getting out into those areas that used to be wet meadows and are bone dry this year, and they're harvesting sedges and rushes. And your sedges are your boat-shaped, V-shaped leaves, and your rushes are hollow, round stems. But it's the seed heads of those plants that are like burrs, and they can cause a mastication tongue problem depending on what species it is. And then I'm seeing some flushes of white clover and red clover in those fields where the Timothy stopped growing, the orchard grass stopped growing, but there was just enough rain, like in your lawn, when you mow your lawn in the spring, you get a flush of white clover. And that white clover can be a problem, as we know, for horses. But if you have too much dried red clover in your hay, you can have an issue with bloat in your feedlot animals. So something to be aware of as you're looking at the composition of your hay. It's more the cuttings later in the year that I think you're going to see some weed species that you're not expecting to see in hay that you're paying that much money for. And I think you're going to be seeing a lot of the pricker species, horse nettle, multiflora rose, dewberry, teasel, your biennial and your annual thistles. And again, those are more of a mechanical injury issue. It's very difficult for animals to chew hay that has mature multiflora rose and Japanese barberry in it. So just be aware of that they may not be eating the bale because of those thorns. And they may get, and the thorns can actually get embedded in their tongues, and you start to see them having some serious mouth problems. But what I wanted you to think about is the fact that now we've got a flush of late season grass coming up in these fallow meadows, these fields that farmers normally wouldn't be mowing, even some set-aside acres that's been released. And that's a good thing because the young grasses that are coming up have nutritional value, but you're going to see a lot of stemmy goldenrod and meadow biennials in those bales. So you have to be kind of aware of the composition of that. There could be some pokeweed in there. And the one I want to talk about a little bit is just become familiar with Indian tobacco. That's lobelia. And lobelia is very common this year. I'm seeing it everywhere. And it would take a lot of it to be baled to be an issue. But we're getting into these areas where they may bale up one whole area of lobelia along near the stream course or in a low area of a pasture that they let grow up. And lobelia contains lobeline. Lobeline, you think of your lupins, and that can cause a condition that's related to crooked calf syndrome. It causes a fetus abnormality in cattle around the 3rd gestation mark, 110 to 115 days of gestation. So just be aware that if you're feeding young heifers or cows in that 3rd trimester, and you're getting into some hay that you're questioning the quality, you want to be looking for Indian tobacco. Oh, and the last thing on Indian tobacco before I move on is that it has a chemistry that's detectable in the horse racing industry. So be aware of that if it comes up in your hay. So look at pest pressure, that changes from year to year. So I'm just touching on a few here that might show up. Our early season hay, we could have issues with botulism. That probably is only a concern for someone who's feeding hay straight out of the field, because that botulism would dry out and disintegrate over time. There's been a lot of armyworm in hay this year, but it's not a known concern as far as a feeding issue. But there are a lot of spiders out there, and those spiders can move into your establishment. So just be aware there may be an increase of spiders, and mice and snakes can also lead to a botulism problem. That's more of a concern in baleage, but I have seen it in dry hay as well. It's the cuttings later in the summer that I want you to think about. Mice and snakes or botulism, and you could run into some of those venomous pus caterpillars down in the south if someone baled along the forest edge. They're pretty distinctive looking. I don't think that would be an issue, but that could happen. So always be aware that if you get that bale that has all the leaves in it and sticks in it, there could be some other things in there that you don't want to feed. Did have enough heat units this year for ticks, fleas, and straw itch mites to show up. And the ticks we already know have all a host of problems, but the fleas and the straw itch mites and the free-living orbited mites, they're the intermediate host for tapeworms. And so while you may have a really good handle on your tapeworm worming program, but you could actually introduce tapeworms into your barns and into your pastures this year, just because of the weather situation that we had. And the last one I'll touch on there is, well, before I go to the next slide, this is just what those little those itch mites look like. If you've ever been bitten by them when you're handling wheat straw or any kind of bale. And then the life cycle of the flea and when that tapeworm is there. And this is information that is out there I've listed the links here. And then as far as the mites being an intermediate host for tapeworm, this is an excerpt from the Medical and Veterinary Entomology book, which is a really good publication. And if you can get your hands on it, there's a host of information there. The last one I want to touch on is, I'm sure if you've had horses, you're aware of this. There was a fatality, a large fatality, mortality in horses out in Wisconsin this summer because of blister beetles in the alfalfa hay. And there was just such a sheer flush of them in the hay that it was an unfortunate situation. But there's pockets of that throughout the country. So if you're feeding alfalfa hay and you know that hay is coming from out of state, you want to be aware of the incidences that can arise from blister beetles. So to end the presentation, I want to talk about toxins that aren't pest related, and that's related to soil nutrients. We can always have an issue with lead coming up in some of our crops, or in the water system. But I want to talk here about two, which is your cation exchange and what's called luxury consumption of fertilizer that can occur in those grasses and alfalfa. And that goes back to the perfect storm we had this spring. With the cold weather, farmers would have been putting out manure, they've been putting out potassium to bump up those crops, and then we didn't have the weather, and those crops, it's called luxury consumption. And there's two issues there. One is grass tetany, when you get an imbalance of potassium and magnesium and the cows are turned out in the spring, and also what's called hypercalcemia at parturition, when there's too much potassium in the hay. So there's a desired ratio that we're looking for. It's more magnesium than potassium. It's 1.5 magnesium to 1 of potassium to prevent those grass tetany and hypercalcemia incidences. And if you're testing your forage, you want to see your potassium lower than 2.5%, which is probably highly unlikely in any of the regions where they were pushing that crop, hoping that we would get rain and they would get an increase in yield. And I have a link here to a fact sheet out of Wisconsin called How You Get Lower Potassium in Your Forages. The other two I want to touch on are later in the season, and that's your nitrates accumulating in pigweeds and sorghum Sudan. And we generally wouldn't see pigweeds in hay but a lot of producers are getting out into that acreage to make more bales to get out to producers who are looking and asking for hay. So they might be baling those cover crop acres that were row crops the previous year, and those may have been acres that were receiving a high amount of fertilizer or manure. So we want to be aware that if we start seeing pigweeds in the hay, we could have parts per million of nitrates that are too high, which would be above 1,000. And then there's sorghum Sudan grass, or your warm season grasses. And there's a lot of food plots that go out, and there's significant acreage that someone might decide to bale that. So just be aware that if you start to feed a warm season grass, you may want to test it for nitrates. And the last one I want to touch on is selenium. Selenium is not something that we have focused on here in the Northeast, but there are plants in the aster family that are selenium accumulating plants. This is usually out west. This is a picture here of a woody aster, which is known, it's called xylorhiza, and it accumulates a lot of selenium and causes a lot of livestock deaths out west. So the rule of thumb is if your forage is less than 0.10 parts per million of selenium, you're actually deficient, and your animals can be born with what's called white mussel disease or rickets deficiency. So during those 2 years ago where we had all that rain, we had very poor quality hay. And most of us who were background in cattle were giving our calves and our sheep selenium shots in the spring because they were deficient. But there's also the concern that you could have these weeds in your hay that could be too high in selenium. And that disease is called Alkali Disease. So if you look at this map here from the USGS, it just shows you where the selenium range in parts per million are across the United States. So you can see out there in the rangeland where they're grazing all the cattle, there's a lot of areas with high selenium. And those plants are accumulating that selenium over the growing season. But we also have some pockets here in the Northeast, and I'll focus in on that. I'm sure you've seen alkali disease in your working with animals. It's a dullness and lack of vitality in the coat. The coat can be very rough, loss of hair around the mane and tail, especially around the tail switch in cattle. And one of the things I focus on is the hoof issues. If you think about your donkeys who get that horizontal ridging and cracking, that may not always be a founder issue. That may be because they were eating plants that had accumulated selenium. So if we focus in on the Northeast and think about the acreage that I said the hay was coming off of, the fact that we're having a shortage of hay, so producers are mining hay off of ground where they may not have taken it off before, we do have areas here in the Northeast that are on the high end of that range for selenium. And usually we see selenium toxicity in arid and semi-arid climates, which would be the out west, where they have less than 20 inches of annual rainfall. But we actually had a microclimate this year where we fit that description. So it's cumulative with soil pHs above 7, soils developed from shale. And if you were testing that feed, your ranges are 2.5 parts per million for selenium is considered a marginal threat, and anything over 5 can cause toxicity. And that's important because as we diversify into different livestock, we may see those green selenium blocks in the store and supplement our animals with selenium. And if you're buying a lot of hay and you're questioning the quality, this is something you may want to test for. And that's because let's look at arid climate, less than 20 inches of annual precipitation and soil pH is above 7, and overlay that across Pennsylvania, where we have the deficit of rain this year. And I can see in my mind several counties where we have hay being made that fit that description. So that's my presentation today. I have my resource slides here with a link to everything that you saw in the presentation. And again, my contact information, if you would like to get a hold of me, please do. Thank you. Back to you, Hank.
Awesome. Thanks, Melissa.
You're welcome.
All right. So, like I said before, my name is Hank McNeil. I work for Rutgers Cooperative Extension in Warren County. I'm a senior program coordinator. Tonight, I'll be covering a couple topics about the importance for testing your hay, how to take a hay sample, and nutrient quality, how to read a forage test, your forage test results. Oh, and if you guys have questions, feel free to put them in the chat, and make sure that you send them to the group so that all the panelists can see. I will try to answer if I see them, but there'll definitely be some time at the end of this presentation to ask your questions to Melissa, to me, or to anybody else on the panel. Hay varies in quality more than any other harvested feed. So having an understanding of those factors that affect your hay is very important for you to make a skillful evaluation for your operation. So choosing or producing quality hay can be one of the most important economic considerations for livestock producers. So any nutrients not supplied by your forage has to be supplemented by concentrates, which will increase the total feed bill for your operation. High quality hay has high nutrient content. So we're looking at crude protein, digestible energy, and minerals, and high intake potential and high palatability. Quality hay should be low but adequate in fiber content, free of dust, musty odor, detrimental weeds, and excess foreign material. So why should we test our hay? So you want to know the quality of your hay, especially since you're going to be feeding your animals this product. Melissa talked about this with some of the weeds to be observant of, and forage quality refers to your forage's potential to meet the nutritional needs of a particular animal. And many livestock species use forages as their primary source of nutrition. It's super important to provide animals with the best quality forage that's available. And so you want to use the results from a forage test to create a balanced ration, which is a critical component of your nutritional management plan. Paying close attention to the quality of forages will positively impact the health of your animals and minimize the costs of purchasing concentrated feeds. You can use the information that you would be getting on your forage test to improve your forage quality. And typically, your first question that you want to address is, do I need to change my management? You want to make sure to keep in mind those nutritional needs of the animals when you're reviewing your program, your forage program. So what stage of production is your animal currently in? And Dr. Wessendorf and Dr. Williams are going to be, going into more detail on these topics tomorrow. So as a plug, we have our second meeting tomorrow night, same time, different link. So in turn, these steps are going to help you cut your production and management costs down if you know exactly what you're feeding your animals. So just like a soil sampling is an option or is a tool in your toolbox, your hay and forage testing is also another tool in your toolbox that's important. The best technique for sampling baled hay is to use a hay probe, and that probe is going to be inserted on the side of a hay bale that is most resistant to puncture. So this usually means that for the round side of a round hay bale or the small end of a square bale. A sample is going to be obtained by using a drill or a brace, and then that sample should be a representative of the composition of the hay bales. And so this process is repeated on several hay bales within the sampling lot. Hay from different fields or cutting times need to be sampled separately. Essentially, it's the same principle as taking a soil sample. If it's not the same, you want to have another sample. A forage probe can be purchased online for a little over $100, or sometimes you can borrow them from your local extension office, but not all extension offices are going to have them. Mine is currently missing, but I'll probably end up acquiring a new one shortly. And then there's also videos online from various extension institutions that demonstrate the proper way to take a forage sample. So your goal for taking a hay sample is that the sample should be a representation of that hay composition. And an older method of obtaining forage samples is the hand grab technique. Well, this method is not as accurate as using a hay probe, and it requires a larger sample, a sample container. Hand samples do not provide consistently reliable results, so you should, try to get your hands on a probe and test your soils that way. And unlike having your soil test done, Rutgers doesn't have a laboratory on campus that tests for forage quality, to my knowledge, but there are private labs that you can send your samples to. Each lab will have prices and specific tests to test for. Prices and sample submission guidelines typically will differ, so you can check the websites or call the lab prior to taking your samples. There are many possible tests to perform on forages, but typically you're going to be looking for, or you're going to be getting moisture, protein, and energy that are the most important endpoints for your forage analysis. And typically the standard analysis includes percent dry matter, percent crude protein, percent acid detergent fiber, the ADF, percent neutral detergent fiber, which is the NDF, and percentage of total digestible nutrients, the TDN, which then is calculated from the percentage of ADF. And we're going to talk about the terms in the next slide. A periodic analysis of basic mineral content is also helpful. Other analyses are nitrate, nitrogen, and trace mineral composition, but due to the increased cost associated with the non-standard analyses, they should only be requested when you really need it. And then with the laboratory method, there are two ways that forages are analyzed for nutrient content. You have wet chemistry, which uses established laboratory tests to quantify protein, fiber, fat, and minerals. And then you have the NIRS, the near infrared reflectance spectroscopy, which uses light transmitted through the sample to estimate the components of the feed. The NIRS has been perfected to quickly, economically, and accurately measure nutrient content without destroying the sample. Also, the NIRS technology uses light reflectance and works best with large compounds, such as those that compose of protein and fiber. And then the minerals are smaller, so it makes it a lot more difficult to measure with the NIRS system. So you typically would use the wet chemistry if you needed to know the precise levels of those minerals. So then understanding your hay test results, most of the time, if you're not familiar with the abbreviations or the terms, it can be overwhelming when you get your hay or your forage test results back. So these are the things that you should be looking for when you're reading your results. Moisture is the percent of water in a sample, and as fed is the actual feed. So it's including the moisture content as it is offered to the animal. And your dry matter is the feed without the moisture. So it represents everything in that sample, including the protein, the fiber, the fat, minerals, and the carbohydrates, and that's without the water. When balancing rations for livestock, you want to make sure that you have the correct percentage of the dry matter. This is important for determining the actual quantities of feed to give your animals to meet the nutritional needs and the performance expectation. So like what we were talking about in the first slide, or in the beginning of the presentation, about depending on your animal's stage of production, they're going to require different nutritional needs. So dry matter basis means nutrient results from a sample with that water removed. Feeds vary in their moisture content, but nutrient content of feeds can be compared directly by disregarding the water. Another thing to look for is your crude protein, which is an estimate of the feed's protein content. Most forage has a range of 4% to 24% crude protein on a dry matter basis. Laboratories measure the nitrogen content of forage and then calculate the crude protein as percent nitrogen times 6.25. And that factor 6.25 is used because protein is approximately 16%. Crude protein also includes both the true protein and the non-protein nitrogen. And then this always trips me up sometimes, but you have your neutral detergent fiber, the NDF, which measures the 3 cell wall components, your hemicellulose, your cellulose, and the lignin. These carbohydrates gives a plant its structure. The cellulose and the hemicellulose can be partially broken down by microbes in the rumen to provide energy to that animal, but the lignin is not digestible. Because of its bulk, the NDF is negatively correlated with feed intake. So pretty much the higher the NDF percentage of forage, you're going to see a lower intake. The acid detergent fiber, the ADF, is a measure of cellulose and lignin. It's negatively correlated with digestibility. So the higher the ADF percentage of a forage, you're going to see a lower digestibility. And then we have our non-fiber carbohydrates. So your NFCs, which are starches and sugars that are inside the cell that can serve as an energy source for the animal. Your water-soluble carbohydrates, the WSC, are part of the non-fiber carbohydrates. The WSC includes several types of sugar that are soluble in water, which are your fructans. It's important to note that the WSCs don't include starch. Then you have your ESCs that are the ether-soluble carbohydrates, which are also part of the non-fiber carbohydrates. The ESCs include several types of sugar that are soluble in ether, but they contain only a small amount of the fructans. The ESC do not include starch. Then we have crude fat. Crude fat is comprised of fats, oils, and other compounds soluble in ether. Fats and oils contain 2.25 times the energy found in carbohydrates and proteins. So they can be added to rations to increase energy concentration when feed intake is limited, which is essential for life. For livestock, specific energy requirements have been determined for reproduction, lactation, growth, and maintenance, like we were talking about before. Total digestible nutrients, your TDN, can be calculated several ways. Basically, the TDN is the sum of the digestible protein, the digestible carbohydrates, and 2.25 times the digestible fat. So for ruminants, the main TDN value on the lab report is going to be is for the use in ruminants, and so then your non-ruminants. So for horses, a separate TDN for horses may be listed, usually at the bottom of your report. Digestible energy is total energy of the feed minus the energy remaining in the fecal matter. And for non-ruminants, be sure that you use your digestible energy for horses if you're formulating rations for them. And then for minerals make up 3 to 5% of an animal's body weight on a dry matter basis. They are classified into 2 groups. You have your macro minerals and your micro minerals. Minerals can't be synthesized, so they must come from the diet. So feed plus a mineral supplement. And so in this table, you can see forage quality standards for hay production measured in a % dry matter basis. And you can also see the rates for total digestible nutrients for grass and for legumes. And then you also see the crude protein for grass and legumes as well. And it's giving you a scale from excellent, good, fair, and poor, things to look out for when you're getting your test results back. So once you have your forage test results, you can carefully go through each item and consider how the results will influence the way you feed your livestock in your livestock nutrition program. You can use the information to formulate a balanced ration for your livestock or for general feeding decisions. And if you have questions, you can always contact your extension agent or feed nutritionists helping with balanced rations. So good. I'm doing well for time. We have about 10 minutes or so for questions. But again, this is my contact information. If you have any questions for me or want to reach out to me after the presentation, this is my information. So if there are any questions, if you want to type them in the chat box, and the panelists can help answer some of these questions.
Hank, the NIRS is really best made for, like Hank said, larger molecules, things that have organic material in them. Protein has organic material in it. Carbohydrates, fats have organic material in them. For the most part, minerals are not organic matter bound. So when the NIR does its thing with its light scattering and analysis, it really is made more for dry matter, organic matter, carbohydrates, fats, proteins, etc. There's been some work done to look at other minerals, but mostly it's focused on those. There are some handheld NIRS devices out now that are being calibrated. I think they're being used mostly on dairy farms at this point. And I don't know what the price is of them at this point, but it's I think it's a coming thing for people to be aware of.
Cool. So I just got a question. Are there any suggestions on weed control that's safe for horses and livestock?
Would you like me to answer that, Hank?
Yeah, go for it.
Could you repeat the question?
Sure. Are there any suggestions on weed control that's safe for horses and livestock?
Well, during the growing season, if we look at the number of cuttings, we have different herbicides that are being used throughout the growing season. And they have a different range of mode of action and residual in the soil and in the crop. One group is called your growth regulators, which is your 2,4-D, your Banville. In pasture, we use Garlon, Milestone. You might see an active ingredient called clopyralid, which is in, and another one called triclopyr. They have different brand names. Those growth regulators are taken up by the weed, but they're also exuded in the biomass as it degrades. It comes out of the roots, and other crops can take them up. And they're very active when they come out of the manure. So there's, on every herbicide label, there's a withdrawal period, and it'll have a category for lactating animals, animals for slaughter, and milk withdrawal. Each herbicide is different, but for the growth regulators, there's an additional one for manure. So that if you're using those herbicides, and those are the herbicides that we would use to target some of our woody species, like the multiflora rose, and that manure can still have the herbicide active. So you have to be aware of where you're spreading that manure. All of the herbicides that are legal for use in a hay crop have that specification on the individual label, and you would just follow those residual withdrawal periods.
Hey, Bill Banner The other thing I would recommend is making sure you're using a soil test both for your pH and all that, because the first step is to keep the pasture healthy and or the field healthy, whatever you're doing, like for forage grasses. And if we're talking, say, in a pasture situation, really manage your grazing. That would be the other thing. Just as a heads up, Melissa mentioned about the milestone and it tracking through the manure. That's one of the reasons it's actually not in our recommendation guides, because being such a diverse state and people put their manure out, that it could be used in tomatoes or different things in home gardens. So that's kind of why we refrain from recommending milestone.
Cool. All right. So I have another question. Do you have the tables that are animal specific that show the nutritional values? For example, horse, cow, alpaca. Mike, were you planning on talking about that stuff tomorrow?
I assume what they're asking for is nutrient requirements tables for
Yeah.
different species. I'm not gonna. I will a little bit on ruminants tomorrow, on cattle and sheep, a little bit.
So Hank, I can answer a question verbally that was asked in chat. Susan asked about hay for older horses. They live in a barn, or they don't live in a barn, they live outside, they only come in to eat grain, and she typically feeds a first cutting locally grown hay in New Jersey. And I will be covering this a lot more in my talk tomorrow, is about specific, what hays are best for which types of horses. But I will say, depending on their activity level, most of the first cutting hays that I've seen in New Jersey are pretty good for your average, older horse. However, in order to give a more specific answer, as you mentioned in your talk, it would be best to get the forage sample and the forage analysis, just to make sure there might not be any deficiencies that pop up, and to make sure the hay quality that, in terms of the crude protein is, right around that, 9-10% level for them. But if she tunes in tomorrow, I'll definitely have more on that.
Oh, here's another question. There seems to be a lot of buttercup here in Warren County. What's the best way to get rid of it? Bill or Melissa?
Hank, one of the things that probably one of the easiest things we usually just recommend, like the generic spray. It's a timing issue too with it. It's like like a 2,4-D type spray, something like that would be probably most cost effective on it. There's other materials you can use. What usually happens is most people don't think about buttercup until they see the yellow flowers, and usually it's a little bit late in the timing for the application. It's one of those weeds that if you see it the one year, you got to kind of make a mental note. Next year, I've got to get out there and get that earlier with it. That's usually why we have it doesn't come in people's minds until you see it flowering.
Oh, so here's the other question about having a list for labs for testing hay. I know there are certain labs that offer hay testing. I'm not sure protocol wise if we're, what I don't want to miss out on a list. Do you guys have any suggestions for that?
I think that Cooperative Extension, we used to have a fact sheet that listed those labs, but we haven't that hasn't been updated in quite some time. I think generally there's 2 labs I would recommend, and I mean I don't think let's maybe not recommend, but just saying there's There's the Dairy One lab in Ithaca, New York, and then there's Cumberland Valley Analytical Services.
Mike,
So those are
the other thing you can do, Mike, I was gonna say the other thing you could do to side skirt, like not recommending, is go to the National Forage Testing Association, where they list the different laboratories in there, and that's kind of sometimes how we get around that.
Okay.
Or don't recommend them, but say, and what I just put in the chat, Equine is what we use at Rutgers to test our hay. We send that hay out, all of our research hays and all of our forage analysis that we need for research to equianalytical.com. So not that I'm recommending them, but that's who we use. Is that better?
Yeah, thank you. Cool. Well, I don't have any more questions that are coming into me. So I guess I just want to say thanks for everyone for being here again tonight, and we will see you guys tomorrow night.
Yeah, see everybody tomorrow.
Same time, same place.
Awesome.